Welcome to ClickMyProject.com. Our project title is Design and Simulation of a Microstrip Circular Patch Antenna with the coaxial feed using COMSOL. And this is our abstract. A method for designing a patch antenna with the circular polarization to be resonant at 9.2 GHz for radar application. It aims at overcoming the drawback of a single patch antenna. The existing single patch antenna resulted in a gain of 6 dB. To improve the gain further, the proposed model consists of a synchronous array of 4 linear elements designed to produce the circular polarization at the desired frequency. Simulation of an array resulted in a gain of 8 dB with an axial ratio 2.9 dB. The return loss for the patch antenna was found to be minus 20 dB to 9.2 GHz. This is a project objective to enhance the better stability, to improve the performance, to maintain the stability, to design an antenna for a communication. And this is a block diagram. First of all, we define the parameter and designing our antenna, and optimization is done, and analyze our result and how the performance is done. And this is a block description, and this is a data of the input, and this is the antenna shape this is our COMSOL platform. For opening this process, go to the file and then new option, and then again go to the file and then open option. This is our file. Go to main and open it. Wait a minute for a opening process. This is the overall process. First step is the parameters uploading. By using this one, we upload the data set. Upload the data set. Then the components. Here we design our model. These are the first of all we design it, and then by designing this, we first of all we define it, and then we use this all geometry, structure, work plane, extrude is nothing but the mixing of extrude is nothing but the plane is mixed with the cylindrical wave, and then outer feed and inner feed, interactions and intersections and spheres, and add materials. Here we use the air, and then RO403C and PITF, and then copper, and then here electromagnetic waves. Here only we include our equations. First one is the wave equations, and then perfect electric PEC, and then initial value, and then far field domains, and then here the miss. Here miss only we just see this miss. It's a shape 1, shape 2, shape 3. So only we define the radiation pattern, and then we are the studies, and then results. First one is the electric field. This is a electric field result. Electric field in which electric field is acted, and then S parameter, and then Smith plot. Smith plot is nothing but the reflection graph, and then 2D radiation pattern. This is a 2D radiation pattern, and then 3D radiation pattern. This is a 3D radiation pattern, and then this is a electric field, and this is a horizontal magnetic field, and then 3D pattern again is the radiation pattern one, and then it's a gain. We also mention in our attain most of the gain we attain. It's a 7 3.3 nearby, and then this is a E field, electric field which act, this is the E field. This is the overall designing of the single strip antenna. This is the overall design of the single strip antenna.